Appreciate everybody spending a little time to learn about what Plexxi brings to the HPE portfolio. Today we're gonna go into what Plexxi is, how Plexxi was designed, and how we believe Plexxi can help HPE and its customers moving forward. We're going to start out by talking about HPE's journey to simplify hybrid IT, or the road to composability, as some folks refer to it. And that starts with traditional infrastructure. That's your traditional silos, compute, networking, and storage that are foundation of all IT. They are siloed. They do run pretty much any workload you'd like, but they tend to be a little complex, and it takes a little bit more time than we'd like to see to deploy applications. One of the reasons why folks began to deploy newer applications out in the public cloud. The next step in the journey was converged. And while the initial releases of converged did help to mask some of the complexity by taking those discrete components, putting them into the same rack, throwing a fancy label on it, they really were more or less simplified the initial installation, but didn't do a lot in terms of complexity moving forward. Some of the newer converged platforms that were coupled with software, such as the HPE Synergy, did in fact go after some of these additional complexity points with the software, enabling folks to leverage templates, enabling them to basically use software to spin up or spin down environments. And that was mostly on the blade side of the house. And then the next step is the hyperconverged option. And with hyperconvergence, it's really the first time we've seen a new form factor introduced into the data center. Now, that form factor brought compute and storage together, negating the need for a SAN fabric and allowing customers to deploy much quicker. Software integrated into these hyperconverged deployments did enable folks to more easily manage these environments. In some cases, they would plug into existing management stacks like vCenter, and they really started to go after some of the inherent complexity with the separation of the platforms. But as I referenced earlier with the three-legged stool, the one piece that hyperconvergence missed was the network. Well, that's one of the big reasons why HPE acquired Plexxi. By coupling Plexxi with market-leading products like SimpliVity, we now have the ability to bring to a customer a solution that is end-to-end and has integration points that the competitors in this space will have to bring along additional software, dramatically driving up their cost points. So it's a great story when you put Plexxi and SimpliVity together, but that we're only getting started there. The next great step in this journey is composable. And if you think about composable could be that data center building block that folks are looking for, where maybe you have racks and racks of HPE servers, and at the top of each one of those racks, you have a pair of Plexxi switches, and you've basically deployed an on-premises cloud. That on-premises cloud includes all the tools you'd want: servers, network, storage. And now you can leverage software through products like OneView to use templates to very quickly spin up identities, if you will, on top of the hardware. So one of those identities may be a hyperconvergence, where you say, you know what, I'm going to take these hardware assets here within this environment, I'm going to make that an HCI array. You may choose to leverage your Kubernetes or OpenShift. But the point is, when you now couple software with hardware in an intelligent fabric like Plexxi, you now can actually deploy a cloud-like experience, and you've got the full suite integrated. So, let's start out by talking about where we are in the industry. We've spent the last several years debating whether workloads should be on premises or out in a public cloud. But the fact of the matter is, those battles are really over. Because at the end of the day, cloud is not really a destination so much as it's an experience. And if we look at what customers are looking for, they want simple, they want scalable, they want cost effective, they want high performance, they want low latency, they want all these things. But they want all those things whether it's in your own data center or whether it's sitting out in a public cloud like an Azure or an AWS. So we have to make sure that we can actually provide all of this functionality regardless of where that customer wants to put those workloads. So when we think about, that stack I referenced earlier, and we think about, at the end of the day, what a customer's trying to do, they're trying to deploy applications. And so if we look at, the components to building a cloud strategy, and we look at what the public cloud providers have done, they've taken applications where there's been lots of innovation, right? Container technology, microservices, scale out architectures. They've taken that, they put it on top of an intelligent data center fabric, and then they're accessing their compute and their storage. Also two places where there's been a ton of innovation, whether we're talking about, high core counts, or we're talking about the advances of memory, or we're talking about, solid state on the storage side, or scale out block and file systems, or even HCI, where these two, tiers come together. The applications are tied to these things through this intelligent data center fabric. The public providers have built it, the hyperscale guys, the Amazons, the Googles of the world. They've built out that intelligent data center fabric, and until recently, that's what's been lacking in the private cloud side of the equation. So if we learn from the innovators and we think about, what are some of the complaints in industry? Well, companies like Facebook basically went out and they built their own network because the traditional networking wasn't going to fit the bill. Google, same thing. Google looked at traditional networking and said it would be too expensive to procure it. It would be too costly to manage it. Never mind install it at the scale they were looking to. So they went out and they invented their own. James Hamilton over at Amazon, very famous for stating that data center networks got in his way. They also went out and built their own network. Gartner, one of the more recent articles, talking about how if you're looking for innovation in the network space, stop looking at existing network vendors because it's not coming. They are iterating and they are moving technology forward, but they're doing it slowly and not innovating. And that's natural, right? If you think about the innovator's dilemma, the whole premise of that is that larger companies struggle to innovate because they're bound to requirements from Wall Street, or they're bound to protecting revenue streams. Regardless of the reason, we see it time and time again. As companies get larger, innovation kind of wanes, and they have to do more acquisitions to bring great technology into the fold. Gartner agrees with this, and they say you have to look at the hyperscale folks, those Amazons and Googles, etc., for real innovation in this space. Network World, just piling on. One of my favorite quotes in the Network World article says that traditional networking is a boat anchor to agility. So all these folks are coming together and saying that just networking has to change, including the most recent one. Chuck Robbins from Cisco came out and admitted that Cisco had made networking so complicated that folks were afraid to change things. Folks were afraid to, move forward with new technologies because they just didn't want to break the existing network. So even Cisco is admitting that we have to simplify computer networks moving forward. I'm glad they agree with that because that was the premise of how Plexxi was founded. Now, Plexxi took a look at what these hyperscale folks were doing, and they said, if we were going to do networking differently, if we were going to get out of, the protocol soup that exists today, layer 2 here, layer 3 here, let's VXLAN this and that, right? And just build networking simple, what would we do, right? So what did the hyperscale folks do? Well, Google, believe it or not, took some lessons from the traditional data center space, and they applied that to how they built out their network. And it was build things to scale out, make sure you logically centralize, use commodity components to keep costs down, and never ever manage singlets of anything. So manage everything as a unified whole. Makes sense. Plexxi took some of those core principles, and we basically productized what the hyperscale folks had built. Google Ventures was an investor in Plexxi prior to the HPE acquisition. And after doing a long due diligence, they finally joined the team. And they joined the team and they said, the reason why we're investing is because we believe that you guys productized what we built internally. Now they built it, custom built it for a handful of applications. We designed ours to be a multi-workload fabric, capable of supporting customers who had varying application requirements and demands. But regardless, Google thought we'd built a remarkably similar network to what they did, and so they invested in us. And the core principles of that network are one system. Back to the earlier comment about never manage singlets of anything. Instead of managing a bunch of devices, we now manage one system. All those devices, when they're plugged in, all those switches will automatically see each other, discover, set default topologies, and boom, you're forwarding packets before a human even has to do anything. It's 100% software defined. By turning on integration points, we can automatically understand the intent for certain use cases and write automation to actually automate those things, right? So we have 100% defined fabric, meaning we don't have to continually recable things to change how the network behaves. We are built on HPE components. Those are also commodity components, if you want to call them white box switches. That's the Alta line. We have deep API integration. We can talk to other things. They can talk to us. That allows us to harvest information to provide more intelligence to the fabric and to do some of these automations, but also allows these other things the capability to do the same with us. And finally, when you do all those things, you've built a true on-prem cloud fabric where you can actually deploy any workload anywhere at any time. So let's talk a little bit about the current state of infrastructure. When we think about networks, right, and this is not being crass, right, this is a fact, right? Networks are built to be simple and dumb. If you look at some of the big brains in the networking space, some of these PhDs at university that spend their careers doing networking and stuff, they talk about how the best you can do in the networking space is to be random, right? Because you're never going to understand every packet or what the real meaning behind that packet or where he's going. So your job is to be as random as possible and just pass packets as efficiently as you can. Now we cheat a little bit with QoS, right? We can start saying, well, let's protect this voice traffic or let's protect this. But the fact of the matter is, networks are built to be simple and dumb. We install a switch, we configure that switch. We then tell him how to talk to another switch. Rinse, repeat. And then once everything is working and tested, we kind of slowly back out of the room and say network is working, right? Let's leave it alone. Modern networking techniques referenced here, such as leaf and spine, where you see the bottom of all your leafs. Those leafs go up to aggregation switches called spines, and that's how leafs talk. If one leaf wants to talk to another leaf, he goes up to a spine, back down to the leaf, right? That's a typical simple, dumb, fixed network infrastructure. Now, if we look at the data center side of the house, where we've got compute and storage, that is not what you would ever describe as fixed, right? Applications are constantly being spun up or spun down. We're seeing, new things added, new servers added, additional storage added. It's a very dynamic nature. So what we have is a mismatch. We have a static network in a dynamic data center. So we're kind of at. So what if we could actually look at the data center fabric differently and say, let's apply newer topologies where, we don't have to have these aggregation switches, which tend to cost the most money. These are the spines I'm referring to. They cost the most money. They do the least amount of work, right? But it makes sense. They cost them a lot of money because they're aggregators, right? All these leafs have to funnel their traffic up to that spine to talk to other leafs. What if all the leafs could talk to each other? What if the leafs could all be connected together in a nice, beautiful mesh fabric where we don't need the additional cost of spines? Well, that's how Plexxi likes to deploy their fabric. Now, we can do spine leaf. So if you're religious about clo and trees and all these things, then Plexxi can be deployed in a spine leaf fashion. But if you look at your network not as religion and more as a resource, then we have a better way of deploying networking that's going to save you money and also allow you to reduce some of the ongoing costs, which is really the bigger problem in networking today. For every dollar you spent on CapEx, there's somewhere between $12 and $15 spent on the OpEx side. And that's really what automation is designed to go after, make things easier. And that's where this smart brain comes in, right? Environmental awareness, right? By turning on some of these integrations and creating special policy across the network, affinities are one of those policies, we can actually create automation where we understand the intent, and then we can create automation on those workloads and make life a lot simpler So what if I told you you could leave your existing static network alone? You've built it out, it works, leave it alone. But now, on the data center side of the house, pair your dynamic data center resources with a dynamic composable fabric from HPE. Well, that's what Plexxi has brought to the table for the HPE family and their customers. We don't have to settle for the same old networking. We don't have to continue with the challenges that folks are experiencing in networking space, right? We can have a network that can be driven by a cloud administrator instead of a CCIE, and that's built for a dynamic environment, built for things to change. More of a static environment. So again, why would you build a composable fabric for a data center edge? Well, let's not disturb that existing data center network, right? It was designed not to be touched, so don't touch it. Let's offload east-west traffic, right? Back in the day, we built these tree networks because north-south was the primary method of how packets moved. Well, now a lot of that stuff is going east-west, right? Well, this fabric, this Plexxi fabric, is designed for east-west traffic, right? So we're going to help extend existing data center life cycles. We're going to help you avoid some additional management and engineering costs. We're really going to get full utilization now out of your data center assets, those servers and those storage, right? And in some cases, maybe that means you don't have to look at a costly software overlay to do certain things. And now we're truly ready for DevOps because we have RESTful APIs. We have CLI if you want it, right? But we also have the ability, if you want to write Python to control the network, you can do that as well. Now we can visualize everything in one pane of glass that allows you to reduce the amount of time it takes to troubleshoot. Right? Imagine being able to see from VM to VM and have that mapped out across, VLANs, across NICs, across ports on a switch, all the way to another VM. Be able to very quickly understand how things are configured. That's what the Plexxi integrations bring to the table. And for a small 10% incremental cost of what you would pay for that rack full of gear, you get all of these things available to you. At the end of the day, customers just want to flexibly and dynamically connect their servers and their stores. They don't necessarily want to have to do a lot of network engineering, right? Not to belabor the point, but networking is very complicated, right? Cloud administrators, DevOps folks don't really care about the underlying infrastructure. They really care about just getting their applications online. It's about business agility, hence the reason why public cloud has had such a good run. Right? If we can provide that same user experience at a much lower price point, maybe that allows those developers to actually make intelligent decisions about where to put workloads versus just putting them out in a platform that allows them to deploy it the quickest. So a picture's worth 1,000 words. So as I like to say, if we think about the evolution of the enterprise data center, let's look over here on the left, and you'll see a 3-tier network, right? Typical old school core aggregation, core distribution aggregation, and then a typical multi-tier data center environment too. Compute resources, SAN fabric, and then storage. Well, around 2010 or so, HCI was emerging. And that really was tasked with simplifying the bottom part of that infrastructure. So new form factors where storage and compute are brought together into the fold, eliminating the need for a SAN fabric. But that didn't solve all the problems, right? You had this great new infrastructure, but you were still held back by traditional networking, right? So imagine, you've got integrated management through vCenter, and you go deploy VMs, you go, oh, wait, I need VLANs. I got to wait. I got to go get the network guys to create me some VLANs, and then they won't be able to deploy after that. Well, that's latency in the process, right? There's a way around that. We could just trunk every VLAN, every port, and every switch. Yeah, you can do that, and some customers do, but that's a horrible, horrible security posture. And in today's day and age, most folks would really rather not do that. Well, if you couple Plexxi with that HCI environment, you now have a hyperconverged network paired with hyperconverged infrastructure that are fully integrated, so you don't have that problem anymore. Because of the integration, when that VM admin or cloud admin goes in to deploy those VMs and creates VLANs, we see that, we automatically create that VLAN on the right port on the right switch at the right time. If that VM gets vMotion for any reason, we see that vMotion, we'll move the VLANs with that VM. Integration allows folks to not worry about some of the mundane tasks now in the data center. Important, but mundane tasks. We free up the network administrators from having to be involved in trivial tasks like VLAN creation, and we enable application folks, cloud admins, VM admins, pick your favorite flavor, to deploy when they need to deploy rather than having to sit around and wait. That's one use case for a Plexxi Fabric when you pair those two. So what else? Well, in addition to composable fabric for HCI, we also have composability in terms of composable rack, or composable ready as we call it today. So back to my comment earlier about customers who are looking for a better way to deploy data centers, a better building block. Imagine today a customer puts a rack of gear in place, a couple top rack switches. That's a layer 2 domain, right? So, every resource in that rack tends to stay in that rack, right? Now you can make the next rack talk to the previous rack, but then you go into layer 3 or a VXLAN, right? You're adding additional complexity. Well, what if every time you added a new rack and new switches, and those switches plugged into the existing switches, that fabric automatically discovered itself and automatically expanded? And every resource and every rack in your data center was available if you wanted it to every other resource. That's the power of Plexxi Fabric. So today, we are transacting composable ready solutions, and those are HP servers, racks of HP servers with Plexxi switches at the top. As we move forward as part of the family, towards the end of the year, you'll see us come out with a composable rack solution with OneView as a manager. So we'll add in some of the templating functionality and definitions I referenced earlier in the conversation to take that simplicity to the next level, and really allow customers faster deployment, better utilization, and a much better all-around solution than what they're probably experiencing today. I appreciate the time. I hope you found it useful, and I hope that you will explore further what HPE Plexxi can bring to the table. Thank you very much.